If you see a function inside another function, so negative 5x is inside of the exponent for this function, think chain rule. And a function inside of another function is what we call function composition. So if you see function composition, think chain rule. Okay. How can we use chain rule to find the derivative of e to the power of negative 5x? Well, I'm going to call the outside function f. Okay, so let y equal, so this is going to be f of u. So this is going to be u, but more on that in a second. So y equals fu, which is equal to, well, what was f again? E raised to some power. E to the power of u. Okay. I'm going to call the outside function f and the inside function g. Now the inside was also u. Okay. Now, if I were to change the u's in this equation to g of x, what would I get? I would get that f of g of x is equal to e to the power of g of x, which is negative 5x. Okay, so this is the same thing as y. Why did I decompose it as two functions? I decomposed it so that I could use chain rule to find the derivative. Okay, so I'll put let y equal f of u, which is equal to 3 to the power of u, and u be equal to g of x, which is equal to negative 5x. So, okay, and then it follows y prime. Well, what's the formula for chain rule? It's going to be f prime, so derivative of outer, times derivative of inner. Okay. Now, what is f prime going to be equal to? So we've got f of u is equal to e to the power of u. What's f prime? F prime is still going to be equal to e to the power of u. We might as well look for g prime as well, because we're going to use that in a second. So g of x is negative 5x. What's g prime of x? Negative 5. All right. Now let's plug it in. Okay. So y prime is equal to f prime. So what should I change this to? E to the power of g of x. And what was g of x again? Negative 5x. Okay. And then times g prime, which is how much again? Negative 5. Okay, so that means y prime is equal to negative 5 e to the power of negative 5x. This is your answer.